Hello everyone. So this is a question from JEE Mains 2026, 8th April Shift 2. Statement 1. Vapors of the liquid with higher boiling point condense before vapors of the liquid with lower boiling point in fractional distillation. Okay. So vapors of the liquid with higher boiling point condense before vapors of the liquid with lower boiling point in fractional distillation. Cool. Statement 2. Vapors rising up in the fractionating column become richer in higher boiling component of the mixture. Okay. So basically, this question talks about fractional distillation, and there are two statements given to us. We have to decide which one is true, which one is false. The chapters involved is GOC. And before we talk about fractional distillation, it is important to understand simple distillation. So this is the apparatus for simple distillation, and this is the apparatus for fractional distillation. Okay. So simple distillation involves conversion of a liquid into vapors by heating, followed by condensation of the vapors, thus produced by cooling. Okay. So that is the whole mechanism of simple distillation. Conversion of a liquid into vapors by heating, followed by condensation of the vapors, thus produced by cooling. Okay, so this is the whole mechanism. It involves conversion of a liquid into vapors by heating, followed by condensation of the vapors, thus produced by cooling. Okay, and this is the diagram. So when we heat the flask, this is the flask, the temperature rises gradually. Simple distillation is used for separation and purification of mixture of two or more miscible organic liquids, provided their boiling point differ by 30 to 50 Kelvin. Very important statement. So simple distillation is used for separation and purification of mixtures of two or more miscible organic liquid. The meaning of miscible is when both the liquids are becoming or forming a solution. So that is known as miscible. So miscible organic liquid, provided their boiling point differ by 30 to 50 Kelvin. This is a very important statement. That is, it is used for separation and purification of mixture of two or more miscible organic liquids, provided they have an appreciable difference in their boiling point. Okay. At the boiling point of the more volatile liquid, that is the one having low boiling point of the mixture, vapors exclusively consist of more volatile liquid. Okay. To understand this, let's see an example. So let's say I have hexane and toluene in the flask. So hexane boiling point is 342 Kelvin, toluene boiling point is 384 Kelvin. Okay. So obviously hexane is more volatile because its boiling point is less. Okay. So around 342 Kelvin, when we heat this flask, the vapors will consist only of hexane. These vapors, as they pass, so I mean, they will rise up and then they will pass through the condenser. So the condenser consists of cold water. So the cold water will condense these vapors into liquid and they are collected at the other beaker. Meanwhile, toluene remains here itself. So this is how we separate them. Okay. But if the boiling point of the two liquids of the mixture are very close to one another, let's say that is they differ by around 10 Kelvin, then separation is not possible by simple distillation. Okay, so important statement. If boiling point of two liquids of mixture are very close to one another, let's say around 10 Kelvin, then separation not possible by simple distillation, because since their boiling point is very, I mean, it's close by, therefore at the boiling point of more volatile liquid of mixture, there will be some amount of vapors of less volatile liquid as well. Okay, so at the boiling point of more volatile liquid of mixture, there will be some amount of vapors of less volatile liquid as well. To understand this, let's say that, instead of hexane and toluene, this time I'm taking two liquids A and B, and A boiling point is 20 degrees Celsius, B boiling point is 25 degrees Celsius, and let's say we heat it. Upon heating them, since their boiling points are very close to each other, the vapors rising up will now consist of A and B both. That's why in the condenser also both kind of vapors are going. That's why in this test tube we'll get both A and B. So therefore we cannot separate it using simple distillation. Therefore, for separation of such liquid mixtures, it is achieved by fractional distillation, okay, which is carried out using a fractionating column. So this is the fractionating column. It usually consists of a long glass tube. So this is a long glass tube packed with glass beads or stones. So these are, glass beads or stones. The purpose of fractionating column is to increase the cooling surface area and to provide obstructions to ascending vapors and descending liquid. Very important. Okay, the purpose of fractionating column is to increase the cooling surface area and to provide obstructions to ascending vapors and descending liquid. So this you will understand that what are ascending vapors and descending liquids. Okay, so looking back into the diagram, clearly this region of the fractional distillation apparatus will be the hottest because we are heating it here, and this region will be the coldest, right? So let's say this is T highest, and let's say this is T lowest. So can you see gradually from the bottom to the top, the temperature is decreasing. So this is, therefore we say that there is a temperature gradient throughout the fractionating column. Okay, so this temperature gradient is very, very important. So temperature decreases from bottom to top. Okay, so let's say that, for example, we have mixtures of A and B. Okay, here we have A and B. So A and B. A boiling point is 20 degrees Celsius. Obviously, at boiling point, liquid changes into gas. Also, the gas or vapor will change into liquid at the same temperature. For B, let's say the boiling point is 25 degrees Celsius. So at boiling point, obviously, the liquid changes into gas. Also, the gas will change into liquid at the same temperature of 25 degrees Celsius, right? And clearly A is more volatile and B is less volatile. Okay, so upon heating, the mixture starts boiling, right? So we are heating both of them, it starts boiling. Vapors will consist of, as I mentioned, both A and B because their boiling points are very nearby. And obviously, there will be a temperature gradient set up in the fractionating column. So let's say that the temperature gradient is like this. So let's say this is 60 degrees Celsius, the hottest, then 50, 40, 30, 20, 10, right? So as the vapors travel up the fractionating column, they will be traveling up the fractionating column. Vapors of B, that is the less volatile component, this guy, condense more readily than A, that is A is the less volatile component. Okay, so B condenses more readily than A. Very important. B, or the less volatile component, condenses more readily than A, the less volatile component. Because temperature at which vapor B becomes a liquid or condenses again is 25 degrees Celsius. Okay, so at this particular temperature, B, vapor B becomes a liquid or condenses again. For A to become liquid, it will need to travel even more up the fractionating column as it needs lower temperature, that is 20 degrees Celsius, to condense. So this is for B and this is for A. Therefore, vapors rising up. So B becomes a liquid here and it falls down, and A rises up. So the vapors rising up is richer in A, or the more volatile component, and the liquid flowing down is richer in B, or the less volatile component, right? So I will write A more volatile, B is less volatile. This process is repeated. The vapors of A escape into the condenser and consist mostly of A, and we collect it in another beaker. So we collect A here and we are left with B in the original beaker. This is how the fractional distillation works. Okay, so statement 1 says that vapors of the liquid with higher boiling point, in our case it is B, condense before vapors of liquid with lower boiling point, which is A. So there, so the statement is saying that B condense before A, correct? As there is a temperature gradient in the fractionating column, and from bottom to top, the temperature decreases. Therefore, the higher boiling point liquid, that is B, will condense first. So it condenses here and it becomes B, liquid B. Meanwhile, the vapors of A keeps on rising. Statement 2. The vapors rising up in the fractionating column become richer in high boiling component of the mixture. It is false because due to temperature gradient, for liquids with low boiling point, that is A, to condense, they have to travel higher. Yes. Since the temperature decreases from bottom to top of fractionating column. So therefore, vapors rising up in the fractionating column become richer in low boiling component, or A, or the more volatile component. Okay. So the vapors rising up is of A, which is more volatile, or having low boiling point, and therefore statement 1 is true, statement 2 is false. This is true, this is false. Okay, thank you.